Welcome to this session on security engineering, part of our CompTIA SecurityX CAS-005 video series. Today, we are focusing on topic 3.2.2, analyzing requirements to enhance the security of endpoints and servers. Specifically, we'll cover configuration management, mobile device management or MDM, and several adversary TTPs, which stand for tactics, techniques, and procedures. Let's begin. We'll start with configuration management. Configuration management is a disciplined approach to maintaining the integrity and consistency of hardware and software systems over time. It involves defining a secure baseline configuration and continuously monitoring changes to that baseline. A baseline might include settings for firewalls, operating systems, installed applications, and more. Imagine an organization has 200 servers. Without configuration management, one incorrect change on just one system could open up a critical security hole. That's why tools like Puppet, Ansible, or Chef are used to automate configurations, enforce security standards, and detect unauthorized changes, something we refer to as configuration drift. Next, let's talk about mobile device management, or MDM. With the rise of remote work and bring your own device policies, securing mobile devices is now essential. MDM solutions help organizations monitor, manage, and secure smartphones, tablets, and laptops. Key features of MDM include enforcing strong password policies, enabling full device encryption, pushing security updates remotely, and remotely wiping lost or stolen devices. For example, a healthcare organization using MDM can ensure that all staff phones are encrypted, run only authorized apps, and are remotely wiped if misplaced. Now, let's dive into adversary TTPs, tactics, techniques, and procedures. These describe how attackers operate throughout an intrusion. Understanding TTPs is essential for defending endpoints and servers. Let's begin with injection attacks. Injection is one of the oldest and most dangerous types of attacks. It occurs when untrusted data is sent to an interpreter as part of a command or query. The most common example is SQL injection, where an attacker sends malicious SQL commands through a vulnerable web form to read or modify data in a database. Other types include command injection and LDAP injection. To prevent injection attacks, developers should use input validation, parameterized queries, and web application firewalls. Next is privilege escalation. Privilege escalation happens when an attacker gains elevated access, such as moving from a regular user to an administrator. There are two main types: vertical, which means gaining high-level access, and horizontal, which means accessing another user's data or privileges. For example, a user may exploit a kernel vulnerability to gain root access on a Linux server. Mitigating this requires timely patching, least privilege access, and monitoring for abnormal behavior. Now, credential dumping. Credential dumping involves extracting user credentials stored in memory or files. Tools like Mimikatz are commonly used to extract passwords or hashes from the Windows or SAS process. Once credentials are dumped, attackers may use them in further attacks like pass the hash or pass the ticket. Mitigation includes disabling unnecessary credential caching, using encrypted credentials, and enabling credential guard on Windows systems. Let's move on to unauthorized execution. This technique involves executing malicious code on a system without authorization. For example, an attacker may send a phishing email with a link that launches a PowerShell script to install malware. Blocking unauthorized execution requires application whitelisting, endpoint detection and response tools, and user training. Next up is lateral movement. Once inside a network, attackers often move from one system to another. This is known as lateral movement. They may use remote desktop protocol, stolen credentials, or Windows management instrumentation to move closer to sensitive targets like domain controllers or financial databases. Preventing lateral movement involves network segmentation, multi-factor authentication, and monitoring internal network activity. And now, defensive evasion. Defensive evasion includes tactics used to avoid detection by antivirus, firewalls, or security monitoring tools. Common methods include using obfuscated code, encrypting payloads, disabling logging, or abusing legitimate tools like PowerShell. To counter this, organizations use behavioral analytics advanced threat detection systems, and endpoint protection platforms that detect anomalies instead of relying solely on known malware signatures. In summary, enhancing endpoint and server security requires a multi-layered approach. Configuration management ensures consistency and baseline security. Mobile device management secures the growing number of mobile endpoints. And understanding attacker TTPs helps defenders anticipate, detect, and prevent sophisticated threats. Always remember, no single solution is foolproof. It's the combination of proactive configuration, intelligent monitoring, and response planning that builds a strong defense. That concludes our explanation of Topic 3.2.2. Stay tuned for the next part in our series, where we'll continue exploring advanced security engineering practices. Thanks for listening and keep learning.